In this video, so we are discussing about that permutation combination last shortcuts. So most important shortcuts are here to solve the problems easily. So let me explain shortcuts one by one. Listen, in this one, so PR, first one is PR, alike of one kind, PR alike of one kind, QR alike of another kind, PR alike of one kind, so QR alike of another kind, next RR alike of third kind. So number of ways selecting at least one, number of ways selecting at least one equals to, that is P plus 1 into Q plus 1 into R plus 1 minus 1. So how can you say this one is example like this? There are 5 apples. How many ways we are selecting? So one may be taken, all are similar apples. One may be taken, two may be taken, three may be taken, four may be taken, five may be taken, and none may be taken. That is 1. P plus 1, Q plus 1, R plus 1, minus 1. Why one we are subtracting is none of them taken is one way. Taking at least one is the number of ways selecting at least one is P plus 1, Q plus 1, R plus 1, minus 1. So suppose in the second, if P are different things, PR, all are different, first kind, first kind means there are different books, there are different 10 books like that. So QR, different, second kind, different, that is very important. Now RR, so are different, third kind. So number of ways selecting at least one. The number of ways selecting at least one. At least one equals to, it is nothing but 2 power n, that is 2 power p into 2 power q, that is into 2 power r, then that is minus 1. So this is, what is 2 power p? So 2 power p means PC0 plus PC1 plus PC2 and so on, PCn, sum of PCP. All none may be taken, two may be taken. Here there are, for example, there are 4 different books. None may be taken, one may be taken, two may be taken. So that is 2 power, that is the sum of all binomial coefficients, 2 power n, that is 2 power p, 2 power q, 2 power r, minus 1. None may be taken, here also 1, that's why minus 1. So these are the different, that is, we are discussing about this one. Now let me explain one more concept of this. So let me explain one more concept of this. Now we are taking that. So now suppose number of devices concept. Suppose given like this. So again I am telling you this third concept is like this. A number is given to you. So how can we find out the number of devices? Let me explain that. A number is given, so that is a power p, so b power q, c power r. So the number of divisors of n equals to, so that is p plus 1 into q plus 1 into r plus 1. So that is the number of divisors. 1 n are called improper divisors. So the number of proper divisors equals to, formula is like this, p plus 1, q plus 1, r plus 1 minus 2. Total number of divisors minus 2 gives number of proper divisors. This is the first shortcut. Previously one question is given like this, n is given as 700. This can be taken as 2 square into 5 square into, that is 2 square, 5 square into 7. Understood? This is 700. This is 25 into 4. That is. So the number of devices. Previous question is like this. Number of devices of form 4n plus 2. So 4n plus 2, n belongs to z. That is the question given. So that is 4n plus 2. That is 2 into 2n plus 1. So odd number multiplied by 2. Only one taken, 2 only one taken. So 5 we don't know, any one of them taken. So that is, so 1 5 may be taken, 2 5 may be taken, none 5 may be taken, 2 plus 1. What about 7? 1 7 may be taken, none may be taken. That is, so 1 into, that is 3 into 2, 6 number of ways. This is the very important shortcut while solving the number of devices in the form 4n plus 2. So this is the very important shortcut while solving the problems. Now, let me explain that number of parallelograms. There are, suppose the question is given like that. So m are the one set of parallel lines, n are the another set of parallel lines. Number of parallelograms are formed. We are giving one more shortcut, giving like this. Suppose given like this, there are m parallel lines of one set, m parallel lines of one kind, of one set. So n parallel lines of another set. Number of parallelograms are formed. It is nothing but, remember that. So that is MC2 into NC2. So based on this shortcut, one question is given like this. For a chessboard, number of rectangles, including squares also, This is, how many vertical lines are there? How many vertical lines? That is 8 blacks, 9 vertical lines, 9C2 into 9C2. So 9C2 is nothing but 36. 36 into 36, 1296. So there are the number of rectangles. Only squares he is asking, suppose. Only squares he is asking about that. So 8 blacks, 8 by 8 is there. 8 by 8 we taken as 1 square plus 2 square and so on. 8 square. It is nothing but 8 into 8 plus 1 and in 10 plus 1, 2n plus 1 by 6. This is the formula. So 1 square, 2 square, this is the shortcut formula. So 8 by 8 is there. So suppose this is n lines. N lines is like this one. 1, 2, 3, 8. Here is 8. Here is 8. So 1, 2, 3, 4, 5, 6, 7, 8. So this is. So here 1, 2, 3, 4, 5, 6, 7, 8. So here that is 1, 2, 3, 4, 5, 6, 7, 8. How many squares are possible? That is 8 by 8. 8 by 8 we are taken as like this formula. If you simplify, this one is 204. So only rectangles means that gives 1296 minus 204. So 1296 minus 204 gives 2, right? That is 1092. So that is 1092. So this is about the solving the problems. Understood clearly? So very important shortcut. This is very important. Now let me explain the de-arrangement. That's a very important shortcut while solving the problems. What is meant by de-arrangement? What is meant by de-arrangement? De-arrangement is like this. There are, suppose, n letters and envelopes. Every letter is placed in one envelope. How many ways everyone is not going to their own letter, own envelope. Suppose 5 letters are there, 5 envelopes are there. So corresponding letters and corresponding envelope. So dearrangement is like this. So original letter is not going to its original envelope. So that is, suppose n letters are there. So dearrangement means suppose n letters are there, n envelopes. So this is the formula we are using, minus 1 by 3 factorial and so on, minus 1 power n by n factorial. This is the formula for the dearrangement. Suppose one letter is there, one envelope. So placing is only correct way, that is 0 ways dearrangements. So 2 letters, 2 envelopes, all are placed wrong, that is 1 way. So 3 letters, 3 envelopes, all are placed wrong, that is nothing but 2. 4 letters, 4 envelopes, all are placed wrong, that is 9 ways. 5 letters, 5 envelopes, all are placed wrong, that is 44 ways. 6 letters, 6 envelopes, all are placed wrong, it is nothing but 265 ways. These are the up to, these 5 are very important while solving the problems. One letter is 1, 1, so correctly placed, there is no ways of arranging wrong, that is 0 ways. 2 letters, 2 envelopes, placed only correct way, only wrong way, that is 1 way. 3, 3, 2 ways. 4, 4, 9 ways. 5, 5, 44 ways. 6, 6, 265 ways. Suppose one question is given like this. So one question is given like this. One question is given like this. So this is dearrangement. Suppose so there are 5 letters and 5 envelopes. 5 letters and 5 envelopes. How many ways? Exactly 3 are wrong. So the number of ways. So 3 letters placed in wrong. Placed in wrong means only 2 are correct. So only 2 are correct. So only 2 are correct. This one, suppose 5C2, 2 are taken wrong. So remaining 3 letters. So 3 letters, 3 envelopes. All are placed wrong. 3, 3 is 2 ways. That is 5C2, 10 into 2, that is 20 ways. Right. So the number of 3 letters placed in always wrong. So that is so only 2 letters are correct, 2 letters are taken, so 3 letters, so ought to be wrong means that is, so that is 3, 3 is only 2 ways, so that is 10 into 2, 20 ways. This is about the dearrangement of the letters. Now let me explain one more concept like this. Suppose sometimes they are asking them some formulas also he is asking. Suppose what is that formulas we are discussing? So in permutation combinations some formulas are there. We are remembering that formulas, easily solving the problems. Suppose one formula is like this. So that is n minus 1 PR plus R into n minus 1 PR minus 1 gives NPR. So n minus 1 PR plus R into n minus 1 PR minus 1 is NPR. Now another formula, NC R minus 1 plus NCR plus equal to n plus 1 CR. NC R minus 1 plus NCR equals to n plus 1 CR. Third formula, NPR is nothing but R factorial into NCR. NPR is nothing but R factorial into NCR. Fourth one is combination concept. NCR equals to n by R into n minus 1 CR minus 1. This is the most advantage formula while solving so many problems. NCR is nothing but n by R into n minus 1 CR minus 1. One more formula now. So that is NCR by NCR minus 1 equals to n minus R plus 1 by R. This is the fifth formula, most advantage formula while solving the problems. So now that is Sum of all binomial quotients NC0, NC1 and so on, NCn, that is 2 power n. So this is also very advantage. So NC0, NC2, NC4 and so on is same as NC1, NC3 and so on. This is nothing but 2 power n minus 1. This formula is most advantage. Now one more formula, the greatest binomial coefficient. The greatest binomial coefficient. It is nothing but NC n by 2, n is even. This is very important. When n is even number, NC n by 2 is the greatest binomial coefficient. Suppose this is A. Suppose n is odd. So n is odd, there must be two greatest binomial coefficients. They are NC, both are equal, or NC n plus 1 by 2. So there are two greatest binomial coefficients, that is NC n minus 1 by 2 or NC n plus 1 by 2. So these are about the formulas. One more generally asking, that is NC0 square plus NC1 square plus NC2 square. This is also asking sometimes in the examination, NCn whole square equal to, that is 2NCn. Generally, this is also asking sometimes, its applications asking the examination. So these formulas, both permutation and combination and per combination formulas, so these are the most important formulas. Now, let me explain another concept like this. Let me explain another concept of, suppose, let me explain the concept of this one. Suppose there are n pair of shoes. This is also given sometimes. There are n pair of shoes. There are n pair of shoes. N pair of shoes. There are n pair of shoes. Remember that. Suppose if you selecting R shoes, if we select R shoes, first one, so no pair at all. So selecting R shoes, no pair at all. First you have to select that, no pair at all, NCR, n pairs. Suppose first one to select in either from 2 pairs, this one 2 pairs are either this one or this one, 2 ways, into 2 ways, it is nothing but 2 power R ways. There is no pair at all, that is NCR into 2 power R ways. So exactly one pair, exactly one pair, it is nothing but NC1 taken. So one pair is there. So n minus 1, C, R minus 1, one pair is there. So 2 taken already. So from remaining n minus 1 pairs, we have to select R minus 2 shoes in such a way that, so from that one is 2 power R minus 2. Right, that is, so 2 shoes are selected, remaining R minus 2 shoes is there, R minus 2, they are no pair at all, it is nothing but 2 into 2 into, that is R minus 2, from R, that is from R minus 2 pairs we have to selecting remaining, this is the exactly one pair. So that is at least one pair, means, so suppose total is 2NC3 minus total number of ways minus no pair. So that is NCR into 2 power R. This shortcut formula very important while solving the problems. Total number of ways, the total number of ways minus total number of ways minus total number of ways minus, so no pair at all, that gives at least one pair, 2NC3 minus NCR into 2 power R. These are the 3 important shortcuts while solving the problems. Now let me explain one more concept is like this. So one more concept is like this. Suppose So one problem previously they are given. I will explain that one. Suppose so that problem you can easily understand that. So right, five balls and placed in 3 boxes. One problem that is have that clearly understanding all the concepts. This is the most important formulas, right? So first try to understand the problem permutations, then solve for that. So there are 5 balls placed in 3 boxes. Each box has the capacity to hold on this, to hold all. So right here is each one having at least one ball. That is the question. Each one having one ball, right? That is the first bit. Here is balls are different. Boxes are different. Number of ways, that is nothing but number of onto functions. It is nothing but formula, that is 3 power 5 minus. So number of onto functions 3c1. So that is 3 minus 1 whole power 5 plus 3c2, 3 minus 2 whole power 5. Next one is 0. If you simplify, this one is 150. So B bit is balls are same. So right, boxes are different. This is the shortcut of given like this. It is nothing but this is positive integral solutions. That is boxes B1 plus B2 plus B3 equals to 5. So that is formula 5 minus 1 C3 minus 1. It is nothing but 4C2 ways. So number of positive integral solutions n minus 1. This is the formula n minus 1 CR minus 1. 5 minus 1 C3 minus 1. It is nothing but 4C2. So that is 4 into 3 by 1 into 2. That is 6. Third one is balls. Balls are different. So boxes are same. So this is nothing but total 150 by total on 2 by 3 boxes, 3 factorial, 150 by 6. It is nothing but 35. Last one is all balls are same. So this is all balls are same. Boxes are same. So that is only the 2 possibilities. 1, 2, 2 possibility. 3, 1, 1 possibility. Only 2 possibilities are there. So boxes are different. Balls are different. Number of onto functions. All balls are same. Boxes are different. It is number of positive integral solutions. All balls are different, boxes are same. It is nothing but total number of onto functions by 3 factorial. This is very important formula. Suppose balls are same, boxes are same. Possibility 1, 2, 2, 3, 1, 1. Only 2 ways. So this is the way of listening this one. So all of you know that. So last that is number of permutations of circular permutations. Circular permutations, all of you know that. In circular permutations, so number of circular permutations equals to, that is, all of you know that is circular permutations. That is last circular permutations. In this one, circular permutations, n things arranged in circularly. So number of ways that should be, that is n minus 1, that is factorial. Suppose, so in case of garland, so garland flowers, arrangement of flowers in garland, or pearls in necklace. In necklace, this one is pearls in necklace. In these cases, so directions are not considered. Both anti-clockwise and clockwise are same. In this case, arrangements are taken as n minus 1 factorial by 2. So actually circular arrangements are n minus 1 factorial. Especially flowers in the garland, pearls in the necklace, n flowers are there arranged in garland. It can be taken as 5 flowers or 10 flowers are there, 10 minus 1 by 2. Why you are taken by 2 means, so anti-clockwise, clockwise direction or consider both. That's why it is n minus 1 factorial by 2. This is the way of solving the permutation combination chapter. So please go through each and every question with strength. You can easily first understanding the concept, then solve it, then you can easily achieve the problems. This completes the shortcuts of the permutation and permutation and combination. Thanking you listening my video. So thank you.